Good afternoon, everyone. My name is Franca Tamaris. I'm the Events Coordinator for the Melbourne Energy Institute. Welcome to our seminar today on the role of natural gas pipelines in the evolving energy system. Before we begin, I'd like to acknowledge that today we're gathered on the lands of the Wurundjeri, Woiwurrung and Boonwurrung people who've been custodians of this land for thousands of years, and we acknowledge and pay our respects to the elders past and present. For those tuning in online, we invite you to acknowledge the traditional custodians of the land you are listening in from as well. Thank you for joining us on the fourth seminar, focusing on gas. We have had some interesting seminars already, which you can catch up on recordings on our website. Also, some instructions for our online audience. If you have any questions, enter them into the Q&A box as the chat function is disabled. And we will have time for Q&A from the online audience and those in the room at the end of the session, and we'll endeavour to get through as many of those as we can. I'd like to introduce you to today's moderator, Professor Richard Sandberg, the Melbourne Energy Institute's new director, who will introduce himself and give you a brief overview of his position and experience. Thank you.
Thank you, Franca, and thank you everybody for coming. And I've been asked to first introduce myself briefly, and I will kind of put emphasis on the briefly to not distract from today's topic. But just as a run through my background, you will see it's got nothing to do with the topic that we're going to hear about today. But I really focus on simulating all kinds of fluid flows and thermal systems. I did my PhD in aerospace engineering in the States, mainly looked at how can you reduce drag of supersonic vehicles, but then spent 10 years in the UK, where we looked at how do airfoils generate noise and how can you mitigate some of those noise generation mechanisms. And that was really related to airfoil noise in aviation context, but also wind turbines. So that's more related to energy already, I suppose. And since 2015, I've been at the University of Melbourne, focusing a lot in turbo machinery applications, so simulating flows in gas turbines, but also developing lower order models that are useful in the design iteration context. So a lot of that work has been with industry and trying to improve design tools. But that's all I want to say about myself. And I guess we want to talk about our speaker today. So it's a particular pleasure to welcome Mark Fothergill, who is the General Manager of Gas Pipelines and Storage Engineering at the APA Group. He leads APA Group's engineering effort for new gas infrastructure projects in Australia and has over 35 years of experience in gas strategic planning, acquisitions, design and operation. And he specializes in concept selection, gas pipelines, operations, and managing project engineering. Since the late 1980s, Mark has been involved in the development and operation of various segments of Australia's gas pipeline network. And he began his career with the Pipeline Authority in Canberra and has played active roles in projects such as the Moomba-Sydney Ethane Pipeline, Victorian NSW Interconnector, Northern Goldfield Interconnector, Western Outer Ring Main, Kurri Kurri Gas Storage Facility, and the formation of the East Coast Gas Grid. Mark has also served as chair of the Australian Pipeline and Gas Association's Research and Standards Committee and as a director of the Energy Pipelines CRC. So I think probably one of the best people to talk about gas networks here in this seminar series. So it's a pleasure to have you here. And thanks again for joining us. We've been trying for a while to get you, and finally you're here. So we're looking forward to your presentation. Thank you.
Thank you. And before I move on, I never thought I'd have a relationship with University of Southampton, but I was working on acquiring the Basslink cable, and it had a failure. Robin, nice to meet you. Had a failure, and so I spent a bit of time with the team at University of Southampton building temperature models of the sea so that we could accurately build a better load management system, so we now can overload the cable safely. Anyway, enough about cables. Let's go back to pipelines. It's a pleasure to be here, and David, also welcome. Glad to see you. I've been doing this for a fair while, so I'm going to keep this presentation at a fairly high level. I'm going to use AMO data, but simplify it so you've got some key takeaways. If you've got questions where you're right to dive right in, I'm happy to take them on. Should be everything I know about. So this photo here is Mondo underground storage, and I thought I'd start here because we're moving to an era where we need storage, and I recall watching with interest the texting between Elon Musk and Cannon Brooks, and we'll build a big battery and we'll do it in 100 days. It was impressive, by the way, 100 days. But as a gas engineer, I sort of went, well, it's 150 megawatt hours. It's sort of like, it's nothing. So I just thought I'd start here and share what that is and what gas can do in terms of firming when renewables are not available, and why they're of interest. So if I set that scene and then we dive down, hopefully that'll give context. So that battery was built, it was doubled. It's now about 150 megawatts and 200 megawatt hours. By comparison, this facility, it holds 18 petajoules of gas. So when you do the maths, that's 17,000 times bigger for the first time around, and then you double the capacity of Hornsdale, that's 12,000 times. So this sort of facility can run a state or a large proportion of the state for a month, and do it easily and comfortably. In terms of bringing it back closer to home, we're in Victoria. The big battery, fair bit of money went into that, 6,000 times bigger, this facility. And there's quite a few of these around, and we can add them. They don't generally cost, they're still expensive and important pieces of kit, but they're not so expensive. Iona, it's bigger than ours. It's about 10,000 times the size of the big battery. So it gives some scale as we go through. We move energy long distances very efficiently, and it's able to provide that flex. So where have we come from? Back in the early 2000s, before 2000s, it was a series of point-to-point pipelines that crisscrossed the country from different gas fields, typically state-owned for a fair while, or Commonwealth government-owned, and then they were progressively privatised. I remember also well in September of 97, Longford had an incident out there. I was working in New South Wales and I had a busy afternoon trying to connect a pipeline that we'd just finished and we hadn't actually commissioned. And we kept the hospitals and a few other things running safely, but we weren't able to run the whole of the state because it was early days for interconnectors. Roll forward to 2003 and a similar event, this time at Moomba, and we had quick commissioning of the Seagas pipeline to keep power and lights on over there. Well, where we stand today, we've got numerous connections, strong connections, and we've got storage options that are far deeper than they ever were then. We've got demand swings that are getting larger, and we'll talk to that during the presentation. There's a range of different contracting from short-term to in-trades to various hubs, and so it's quite a sophisticated market and sometimes complex to follow. But when it gets back to my business, peak demands differ across the network and different times of the year. So if we're looking at Western Australia and the Northern Territory and even into Queensland, typically demands are higher in summertime. So we've got compression equipment that's working fairly hard, struggling to get air, and that's full load. And then in the flip side, when we're coming down into the East Coast grid, it's a winter-driven peak for us. You can see the extent of the pipelines and some new ones that we're proposing. So gas moves vast distances. So let's just put aside Western Australia. I could talk about that at length, but I'll just, as I said, I'm going to work from a lot of data out of EMO, but simplify it to some degree. So on the right-hand side of this chart, you can see a chart which is figure 4 in the latest the gas statement of opportunities. But I picked out the line that really says how much production have we really got going on at the moment right now and forecast to have, and what storage. And then AEMO does a great job of layering and layering and layering what options can unfold to show how the balance is met going forward. But that shows you already that there's a mix of storage and a mix of production that meets the gas market. In other words, there's not enough production on any one day to just produce and service the market. You do need storage to run the business, and we'll need more storage going forward. That can be a mix of renewable gases coming forward, as there's certainly a large opportunity to replace traditional supplies. And I think the other one I'll share here is a rule of thumb that's really easy to remember. It's 1, 10 and 100. And it's pretty close, but if you're looking at a GPG, 1 gigawatt of size, and you want to run it for 10 hours, which is typically sort of overnight or during a wind event or whatever, it'll consume 100 TJ. So when you're looking at the right, you can see that we're looking at fairly significant electricity demands growing, and growing in terms of the network. So let's go a little deeper and look at some demand. I'll just take a little time here. So we spoke about underground storage. This photo is taken from a facility that we recently built to store gas just in a dedicated pipeline bottle. And the reason why we decided to go down this path was there was a really strong electricity connection point, a nice site, community acceptance for the area, and you can see the power station in the background being built. But the location was right at the end of the gas network, and so we had a choice between rebuilding the gas network or adding storage, which we could fill at a steady rate and then draw down when the market needs it. So this particular solution is just starting to operate up in New South Wales. But it shows how you can mix storage and a constrained network and still deliver some very large power station solutions. So jumping forward, let's have a look ahead, and I'm going to look in the 5-year horizon because that's what most things take to build at the moment. If you're looking at a GPG, from the time you think you know what equipment you want to buy, you've got a 3-year lead time and you've got a 2-year build. So I think it's a reasonable sort of time frame to look at, and it also is in the planning horizon of where the market is. I'd like AEMO to probably look at 7 years, so we've got a little bit more ramp up time, but 5 years. So I'm going to run through energy demand, gas and electricity a little bit, talk about some GPG operating profiles and what's going to happen there, and then moving into sort of pathways of how you would leverage existing network to meet these new needs. And the one observation I have is almost every week I'm hearing, geez, the data centers and load and the AI growth is enormous and it's going to require even more power. So I look forward to seeing how those go. The photo on the left, on the right, sorry, look at it. This is a pipeline 600 kilometres long in Western Australia, and it just gives you an idea. We cross vast distances, single compressor, and I'll show you the compressor later. It just pushes gas from one end to the other. And here it's shortly after commissioning, so the right-of-way is still yet to obviously go back into nature, but they do tend to blend back into nature. So as I said, I'm going to duck into, and the reason for warning you on the previous slide is a fair bit on this slide. Firstly, each of the slides I'm looking 5 years ahead. I'm looking at a point. So I'm just trying to sort of say what's happening in 2031, 32. Because if you wanted to start building GPG today, that's when we're going to see new load. We already see GPG running. So what we can see is that the gas demand is falling for domestic users. That's the first chart up here on the top, and it's projected to keep falling. The only scenario where it rises is if we were doing exporting. I think it's green hydrogen and it's export. But all other scenarios, they're falling, and we're already seeing that today. People turn on their air conditioner in winter rather than turning on their gas system, so the loads are coming down. But what we see when we go down to the bottom corner here is the projections are that the peaking power stations will be not running as much, but then when they do run, they'll run harder. So that's what AEMO's projections are showing there. It's a bit hard to see, they're flat or less than, but then the peaks are higher. So the pipelines are going to be required to flow more volume. And the last thing I'll just point to is that in 2031, 32, if I've got my lines right, in terms of announcements, a quarter of the coal fleet today have retired, whereas the modelling suggests that perhaps half the coal fleet in Australia is retired. So there's a little bit of there's quite a bit of uncertainty there from my point of view in terms of what am I needing to achieve and how we're ramping up. So then taking that a little bit further, in terms of those projections to cover the coal closures, AEMO's projecting there'll be up to 8 gigawatts. Now, those 8 gigawatts is not necessarily at that particular time, but it's a growing GPG load, and the outlook is we're going to have some very high peaks. And so to meet those peaks, we'll need a combination of more storage, and we'll need to change the way the pipeline systems operate, and I'll explain that a bit further. This chart I just grabbed, and this happens fairly regularly. This is our weather in the NEM at thing, but we had a 5-day event at the end of June this year. We had great, you can see here, we had a really solid wind. We had a bit of battery operation, a little bit of hydro, and quite a bit of thermal load there behind it. And then we moved into a period where the wind just backed off. And so we had the hydro swing in and run up to its maximum capability and helped out immensely through there. The wind was sort of missing. The solar wasn't as strong. It's still pretty solid there, it wasn't as strong. And there's been an awful lot of fossil fuel. So closing the brown and the black area, which is the brown coal, black coal, what's going to support us through this 5-day period? Because there isn't, that's what we're looking to solve, and that doesn't happen all the time. That might be quite another weeks before it happens again, but then it happens again, and there's sort of a repeating pattern of what to do when the renewables drop off. So hopefully that example, as I said, it happens fairly regularly. So as I said, what do you do with a gas pipeline network to meet these huge loads? So what I've done here on this slide is just showed a hypothetical new power station being built, say, somewhere near Canberra, for this particular example, but we can play this many ways. And I'm just showing the prevailing flow directions as we go forward. So we're looking at some Beetaloo gas joining through the existing networks coming in. We'll get some Queensland gas coming across at the top, and then you get flows coming down into Adelaide through CGas, through EPIC, remember Adelaide system, and then CGas flowing back into Adelaide. Flows coming down the Member Sydney and branching off either into Victoria or into Sydney. And then Longford itself producing gas into Melbourne and also up through EGP into Sydney. And on this part of the page, I've taken the arrows off because I just wanted to show you what happens when you suddenly get a huge load and how those flows. So before I do that, gas moves in a pipeline because you have a high pressure and a low pressure. So if I want to go from this side to this side, I have a high pressure here and I go low. So in the case of, if I look at Young and I'm going towards Melbourne, Melbourne's taking gas away. So I create a high pressure at Young and it flows down to Melbourne. When I want to go the other way around, I need to create a high pressure in Victoria and go north. And so the pipeline will flow the other way. What it means is that that load which was going there can now go to another point on the system. So let me just step forward. And so if you have underground storage, say Golden Beach, but it could be other operations, here, then you can increase the volumes coming out of this part of the network, and that frees up molecules to both service Melbourne and also to push back up into New South Wales. Similarly, it could push back up into New South Wales. Gas that had been flowing down New South Wales to Victoria interconnector can flip around, and therefore you get 2 lots of gas arriving at the top. So you can quickly sort of double the volume of gas going to a power station. You can't sustain it forever. That's why you need storage. It'll last 4 or 5 days. The weather comes back, the renewables are in, and then away we go again. But underground storage is a lot bigger than a battery. So let's just talk about supply. So I mentioned before the Northern Goldfields pipeline. This is the compressor that pushes, it's a compressor station that sends that gas 600 kilometres, fairly modest in shape and size, but moves a lot of energy from the coast or from gas fields along the coast and offshore across to the minerals regions in Western Australia. So what we're looking at is an outlook with fields that have been producing 50 to 60 years are in decline. There's further work going on in expanding and drilling those fields to extract more product useful life out of those particular fields. We're also looking at alternative gas productions that need to be added, be them natural gas from underground sources or renewable gases. When you look at the gas SU, once again, the gas statement of opportunities, it highlights that we don't need to do, we have enough domestic gas to be able to supply ourselves till 2033. I'll talk about that on the next slide. Whilst LNG imports are technically viable, it does tend to appear, it tends to support that it'll be higher cost of gas. And as Paul Simshouse has shown before, there's a link between the cost of gas and ultimately what the cost of electricity is. So we do need to be mindful about which pathways we go down there. The other thought I had around, we have around LNG imports is that we're already producing them in Queensland. So buy the cargo off the producers already and redivert back through the pipeline network and then save the liquefaction molecules and also the shipping losses that go with moving the molecules around by boat. So it's a way of extracting better value from our existing LNG in a virtual pipeline a virtual LNG import arrangement. Oops. So I mentioned that AEMO flagged that we actually don't need. We have solutions in front of us in terms of just modifying our pipelines and connecting different gas sources that take us out to, and these are AEMO's words, 2033, 3034. You can see it in the chart up on the far side where they show no additional supplies or gaps through this period, as long as the pipelines are augmented. And then they've got a very busy chart down here. I won't seek to explain it here, but what it does is it looks at gas production from fields and then overlays the amount of storage and whether it'll cover the period that it needs to supply. It's a great piece of work, and if you want to read more about solutions, AEMO covers that in section 5 of the storage. But this work is something that I've been working and sharing with them, and different strategies about moving gas around Australia. How does that look in terms of our pipeline system? So we're currently sitting in terms of moving gas from Queensland, which is a large potential source of gas, further south through the Moomba Sydney pipeline. We're sitting at around 560 to 580 TJs a day. We don't often operate up at those levels. It's typical Southwest Queensland can get up to these levels, but Moomba Sydney hasn't moved all of these sort of numbers. So demand is still growing, but there's headroom available in existing pipelines. And then we've got a series of staged expansions which will add, sort of circa another 300 TJs. And this is just baseload gas. The idea here is just to move it every single day and fill storage. And then the storage has the opportunity to handle the swings. And so you get this doubling effect. Similarly, if I trace Southwest Queensland through, when we do this expansion with the Baloo interconnect, which was, you saw the dotted lines earlier on my map, it gives us another 20% expansion across that system. And then we could also put some more additional compressors on there and take it up another large proportion. The other, as I spoke before, the other element that I think that we do need in the East Coast grids is we need localized storage, just to reinforce if we have an issue, an underground storage facility, we need to have multiple options. And so some dedicated storages, like I showed earlier on in the story there at Kurri Kurri, probably larger than Kurri Kurri. It's only built for one power station. You need to carry the New South Wales and Victorian loads. So a phased expansion of Riverina storage would then provide the right balance and mix of short-term assets and longer-term assets. So I'll get to some closing thoughts and change theme a little bit. So I just want to talk briefly about net zero. APA's had a climate transition plan. It was a challenging first write. I think once you've got something, you can always read it and go, oh, second time around, I suppose it'll be the same when we sit down with Net Zero Australia. We'll have some feedback and some learnings, and that will certainly be tweaked. But so we published 3 years ago, and so we're having the chance to reflect at the moment and see what we've done. In our document, we're going to have quite a few stats. We're going to talk insights that we've learned in the last 3 years in terms of the journey to how to improve our emissions footprint. But I'll talk to one particular project that we've had a look at. So the photo on the right again, this is Wallumbilla Gas Hub. There's about 15 different pipelines, all of quite significant pipelines that all make their way in and around this area. That's not all of the hub, but that's most of the hub. That's the bit we own and operate. And there's 9 compressors there, and we know at any one time we've got a sort of base load compression, and then there's a peaking and then a really peaky set of molecules. And so we sat down and said, could we get the base economically converted over and run it on something new or something different? And so we found out, yep, there's good 20-30% of the volume going through here is always there. So it's going to give you the lowest cost in terms of replacing or changing. So we sat down with some renewable methane producers and we worked through with them about what supply chain and what it would look like to buy renewable gas to power our facility and therefore lower our carbon effect. We also looked at new electric drive compressors. We're not on the grid really here. We've got a reasonable supply, but not enough to supply that sort of equipment. So it was the 13K electricity expansion from the grid in this particular ocean. And we said, well, that's pretty borderline. So we also had a look at a standalone renewable off-grid facility. We do quite a few of those for mine sites that are quite remote to help lower their gas consumption and use the wind resource and solar resources that are around. Unfortunately, at the moment, all of those are not, they need more work. We haven't got a magic bullet there. And so as engineers, we need to keep leaning into and looking at novel ways to reduce that. But the time we've spent, just reinforced the, things that we need to put in place and the technologies we need to be looking at and driving to continue to get these sort of solutions so that across the board, everybody's leaning into it. In the last 3 years, I've seen many new products all around seals, the way our valves work. So much of our business it's getting better, but replacing equipment that you already got, it's a fairly expensive task. And so certainly the new build sites are very low, and we do work very hard on these older build sites. So just in closing, for me, I look forward to the next round of Net Zero. I love data in my role. And to R&D, David, thanks for the work with Future Fuels CRC and even before that with your time at Energy Pipeline CRC. And we're setting up an association-led research organisation to continue that legacy. We'll try and do it proud. But the Pipeline Association's been at it for about 60 years in terms of research, and we'll continue to do so. So with that, I'll close up and